right, so looking at the very last thing we talked about, given r theta, we know that if I add or subtract a multiple of 2 pi, that I still end up at the same as if I didn't add the multiple of 2 pi. And if I add or subtract pi, I know that that's going to basically flip the sign of r, okay, as far as how polar coordinates are generated. So looking at this example here, when it lists 2 points that are equivalent to the point 4 comma pi over 6, one with r greater than 0 and one with r less than 0. Well, if I want r to be positive, that means I want r to stay positive. So that means one of my points is going to be 4 comma pi over 6 plus 2 pi, which simplifies to 4 comma 13 pi over 6. So there we have that. Now if I want r to be negative, we know that by this idea up here, if I add pi to the angle, I negate the r. So I'm going to choose to add pi. You can subtract if you want to, but I just think adding is just more straightforward. So that would be 7 pi over 6. And if you were to graph all three of those points in polar, they would all land at the same coordinates. So there we have it. Okay. Next, let's write a polar point using Cartesian coordinates. So remember the formulas we derived up above. We had x is equal to r cosine theta and y is equal to r sine theta. So given an r and a theta, we can easily find x and y by just plugging and chugging. So if I'm given the polar coordinates 6 comma pi over 3, just to get an idea what that looks like. So if I'm inclining pi over 3, that's 60 degrees, and I want to go 6 units out. So we're about there, okay? So if I want to convert that to what are the rectangular coordinates of that point? Well, I know that x is equal to r is 6, and theta is pi over 3, or 60 degrees. I know that cosine of pi over 3 is a half, so that means x is 3. And y is equal to 6 sine pi over 3. I know sine of pi over 3 is root 3 over 2, which is 3 root 3. So the Cartesian coordinates of that point are 3 comma 3 root 3. And they're all basically that straightforward. So converting a point from polar to rectangular, not a big deal. Plug and chug. So in our next video, we're going to look at converting the other way. What if I give you the rectangular coordinates? What are the polar coordinates? And that has a little bit more to it. So we're going to spend some more time with that. So thanks for watching this one.